So last time we had talked about mass spectroscopy, and we had talked about, तो थोड़ा सा recap कर लेते हैं कि we had talked about figuring out the number of chlorines. Okay, that was one thing. I told you that if your molecule over here, if it has one chlorine, so what will happen is that chlorine has if you do mass spectroscopy, you deflect the particle in a magnetic field. There would be two different deflections because the chlorine could be 35 or it could be 37. So the mass of the molecular ion would be different. Okay, एक heavy होगा and one of them would be light, and the heavier one would be deflected less and the lighter one would be deflected more. Probabilities क्या थी कि chlorine 35 आने के chances, that's 3/4 and 37 is 1/4, right? ठीक है, ये सारा क्लियर था कि आपके पास ये सारा हमने किया था ना? We did this, right, Mikhail?
Yes, sir.
Okay, so you had so we did this, that 35, 37. The probabilities were that there was greater chance of getting 35. Yani 50, this particle would be detected more, and 52 would be detected less. And then we talked about a molecule having two chlorines. So in that case, we did when you do the mass spectroscopy, the molecule would form an ion, and that ion would get deflected in the magnetic field, and that particular ion will have three different masses. If you have two chlorines, then the masses, there would be three different masses. Okay, either it's going to be both of them would be 35. That would be a lighter version of the molecule. The mass would come out to be 112. One of the chlorine is 37 and the other one is 35. So iski jo mass hai, that would come out to be 114. Or the third one was both of them were 37. So the mass would come out to be 116. So the probabilities of getting, we did the probability thing as well, that the probability of getting, if I do the math over here, the chances of getting 35 is 3/4, and the chances of getting the other one is as 35 is also 3/4. So it's going to be 3/4 multiplied by 3/4, and that gives you 9/16. So this one, the chances, what are the chances of getting both of them as 37? That the first one is 37, the chances of that is 1/4. And the second one is 37, that's also 1/4. So the combined probability of getting both of them as 37 was coming out to be 1/16. Of it, एक 37 and one of them is 35. The chances of that would be that either the first one is 35, so that's 3/4, and the second one is 37, that's 1/4. Or it could be the other way around. Or जब आ जाता है, so that's a plus. Or the first one is 37 and the second one is 35. So it's going to be 1/4 into 3/4. Or that would give you 6/16. Remember, there would be two combinations and both of the molecular ion would give you 114. Either the second one is 37 and the first one is 35, or the first one is 37 and the second one is 35. So that's how you calculated the probabilities. The most likely, किसके ज़्यादा chances? 9/16. So the particle, this molecular ion with the mass 112 is more likely to be obtained. 114, the particle that has a mass of 114 would have a lesser chance, and this would be the least, 116, both of them coming out to be 37. So you'll have three molecular ion peaks, M+2, M+4, and the ratio is going to be 9/6/1. Okay, out of 16 events, 9 of them would be this one, 6 of them would be this one. So the ratio would be the same, 9/6/1. Okay, is this clear? Is this clear?
Yes, sir.
Okay, and the next thing we did was for bromine. Like in bromine had two very abundant isotopes and they had equal probability. So it was 1/2 and 1/2, or 50%, 50%. So when you have a bromine molecule, if it's got one bromine, then I told you that the molecular ion will have, the molecular ion over here will have two different masses. Why would it have two different masses? Because either it's going to be, the bromine would be 79 or the bromine would be 81. But the probability of getting both of them is the same. It's 1/2 and 1/2. So in this case, the mass of the molecular ion would be 94. There's going to be a detection at 94. And if it's 81, bromine is 81, then the detection would be at 96, and it's going to be 1 by 2 and 1 by 2, right? So both of the molecular ion peaks would have equal probability. And we also did this, that what if a molecule has two bromines? So either both of them will have a mass of 79, or one of them is going to have a mass of 79 and the other one would be 81, or both of them would be having a mass of 81. So 3 molecular ion peaks only with 3 different masses, 172, 174, 176. What's the probability of getting both of them as 81? That's basically half multiplied by half. What's the probability of getting both of them as 79? That would be, that would also be half into half. And what's the probability of getting one of them as 79? Either the first one would be 79 and the second one is 81, or the other way around, or the first one is 81, that also has a probability of half, and the second one is 79. So you got 1 by 4, 2 by 4, and 1 by 4. It's 1:2:1. So you'll get 3 molecular ion peaks, and the relative abundance or the amount of detection would be 1:2:1. ठीक है, ये clear है? And then, not sure if we did this one yesterday. What if a molecule has 1 chlorine and 1 bromine? So the probabilities of, we did this?
No, I think the last we did.
We did this one, right?
Yeah, actually we done that. We have done this.
Your voice is cutting. We didn't do this, right?
Yes, we did not do this.
We did this as well, right? And did we do the number of carbon atoms? ये किया था कि नहीं किया था?
So we did till Cl and bromine.
Acha, we didn't. Acha, ठीक है, we didn't do this, right?
Yeah.
Acha, so I'll just sum this up. But is this clear that if the molecule has 1 bromine, right, its molecular ion will have 2 different masses. There would be 2 different masses detected, but they would have equal probability, because either getting 79 or 81, the mass would change, but the detection, they would have equal chances of getting 79 and 81. But if you had 2 bromines, then the mass, there would be 3 different masses, m plus 2 and m plus 4. So anyways, I'm going to do the 1 chlorine, 1 bromine scenario. What if a molecule has 1 chlorine, 1 bromine? Now the bromine will have 2 different masses. It's either going to be 81 or 79, and that's the probabilities of getting either of them. And the other one is, what if it has 1 Cl? So the Cl would either be 35 or 37. And the probability of getting 35 is 3 by 4. The probability of getting 37 is 1 by 4. So if I have a molecule like this and it turns into a molecular ion and I'm detecting the molecular ion, so kitni masses hongi iski, this thing? So it would either be the lighter version, which is either it's going to be carbon and 2 hydrogens, that's 14, plus bromine is 79 and chlorine is 35. So that would give you a mass of 128. That would be your molecular ion. So the probability of getting 79 is 1 by 2, right? I mean, it's given over here. And the probability of getting 35 is 3 by 4. So 79 and 35, that's half into 3 by 4. That gives you 3 by 8. So out of 8 events, the 3 times you're going to detect this particular mass. Is that clear?
Yes, sir.
अच्छा, फिर वो है कि what if carbon and hydrogen, that's 14 plus 79, and the mass you'll also have an M+2 peak, which would mean the mass would be 130. Why? Because either the chlorine is the heavier one, 30, so it's 37 and this is 79, or bromine is the heavier one, 81, and this is 35. In both cases, the mass comes out to be 130. So what is the probability of getting this molecular ion, which has a mass of 130? That would be 1/2 into 1/4. And this would have the probability of 1/2 into 3/4. So it's either this one will give you a mass of 130 or this one will give a mass of 130. So I've summed up the probabilities. There are two different events that would give you a mass of 130, and that gives me 4/8. And the last one is I'll have a molecular ion with a mass of 132 as well. In this case, both of them are the heavier ones. You have the heavier isotope of bromine, which is 81, and you have the heavier isotope of chlorine as well, which is 37. So what's the probability of 81? That's 1/2. What's the probability of 37? That's 1/4. And that gives me 1/8. So I'll be having three different masses again. I'll be having an M peak. I'll be having a slightly heavier peak, and I'll be having an M+4 peak. And the ratio of the heights would be 3:4:1. So the relative abundance, if the molecule has one chlorine and one bromine, the molecular ion peaks would look like this. And they would be in the ratio of 3:4:1. Is that clear?
Yes.
Yes.
Yes, sir.
So last thing, mass spectroscopy. You can also figure out, what you can do is you can also figure out the number of carbon atoms. You can figure out the number of carbon atoms in a molecule. How do you do that? Carbon also has isotopes. So there's going to be variation in masses due to carbon's isotopes. Most of the time, carbon is 12. Carbon has a mass of 12, which basically means and the relative abundance or the probability of getting carbon 12 is almost 99%. And there's 1% chance of getting carbon 13. So let's say if I have a molecule that has one carbon atom like CH4. This CH4 molecule is going to have two different masses. So it's either going to have a mass of where carbon is 12 and the hydrogens are 1. So 12 plus 1 plus 1 plus 1, that's 16. Or there is going to be an M+1 peak. यहाँ पे क्या होगा कि if it's M+1, so why is it M+1? Because carbon could be 13. So it would be 13 plus 1 plus 1 plus 1. So that gives you 17. So this is the M peak. This is the M+1. एक ज़्यादा है, ठीक है, तो M+1 peak. What is the chances of getting 16? It all depends on carbon 12. What's the probability of getting carbon 12? That's almost 99%, right? And what's the probability of getting carbon 13? That's just 1% or approximately 1%. तो आपका जो graph बनेगा ना, there's going to be a detection at 16 and there's going to be a detection at 17. The 17 mass molecular ion will be very less. 99% of the time you're going to get this 116. Is that clear?
Yes.
ठीक है, Abdullah clear? Muneeb, Hamza, is this clear?
Yes, sir.
Yes, sir.
Yes, yes, sir.
Okay. So remember the idea is it could be any molecule like serial bond ON, OH. If it's got one carbon atom, right? So the mass would be, most of the time it's carbon 12 plus 16 plus another 16 plus there are two hydrogens, so that's 2. So that's 34 plus 12, that I think would be 48. I guess it's 48. 34 plus 46, I think. Wait a second. What's 16 plus 16? 32 plus 2, that's 34 plus. So I think that's 46, right? So now the variation is in the carbon. The carbon could be a heavier one, so it could be 13. So if it's 13, the mass would be 47. But 99% of the the chances are that you're going to get 46. There's only For 13, the probability is very less. So there's only 1% chance that it would ever be 47. So that is just an example. So any molecule that has 1 carbon atoms. Now, what will happen if a molecule has 2 carbon atoms? What is going to happen if a molecule has 2 carbon atoms? Now, what is going to happen is, okay, here's a molecule that has 2 carbon atoms. And so here's a molecule that has 2 carbon atoms. So how many masses could it have? So both of the carbons could be 12, 12 plus 12, and 6 hydrogen. So that's 12 plus 12 plus 6. That gives you a mass of 30. So the molecular ion will have a mass of 30. Or one of the carbons could be 13. So the mass would become 31. It would be a heavier molecule and it would be detected less. And the third one is both of them could be 13. That would give you a mass of 32. So is that clear? You're going to get 3 different masses for this molecular ion. You clear?
Yes.
तो
Yes.
अच्छा उससे फर्क क्या पड़ेगा? उससे फर्क क्या पड़ेगा कि what's the probability of getting both of them as 12? That would be 98.9% into 98.9%. If you do the math, that approximately comes out to be 98%. What's the probability of getting one of them as carbon 13? So there would be 2 events that either the first one is 13 and the second one is 12, or the first one is 12 and the second one is 13. In both cases, you're going to get 31. So basically, they're 2 separate events. So it's 1% into approximately 99%. So it's 1% multiplied by 98.9%. That's the chances of getting carbon 12. That's the chances of getting carbon 13. Into 2, because there are 2 events. It could be the other way around as well. But anyways, if you do the math, it comes out to be 2%. And what's the probability of getting both of them as carbon 13? Both of them as carbon 13 would give you 32, but that probability would be very less. It would be so less that these particles, the M+2 particles, would hardly be detected. So we're just going to cross it out. We're not going to be detecting them because their probability is very less. But you would notice a pattern now. And that pattern is, if your molecule had just 1 carbon atom, what was the ratio or difference between the M+1? It was 99:1. Now your molecule has two carbon atoms. So now your molecule has 2 carbon atoms. Just 1 second. So the ratio of the detection, or the probability of the detection for detecting the M peak, has sort of decreased, and detecting the M+1 peak has kind of very slightly increased. Just 1 second. अच्छा, तो ये बात समझ आइए कि there's a trend that you would notice. Do you notice a trend that as the number of carbon atoms increase, so the detection ratio between the two, it's kind of slightly different?
Yes.
So what do you think? Okay, if the what do you think if the molecule had 3 carbon atoms? फिर क्या होगा?
97
and 3%.
ठीक है, so it's going to be 97 and 3%. I mean, the probability is what? So we can sort of just confirm that. So we can confirm that. So let's say there's some random molecule. I'm just going to draw a random molecule that's got 3 carbon atoms. So let's take propanoic acid, for instance. So in the ionization chamber, it will turn into an ion. It will be deflected. So it's got 3 carbon atoms. So the mass of this molecule would be, so it's that's 32, 2 oxygens. So I'm talking about the M peak, M+2 peak, M+4 peak. Let's talk about the heaviest peak first. Not M+4. let's start with the M, the lightest one, कि जिसके अंदर दोनों कार्बन हो, ठीक है, the M peak, carbon 12 हो. So it's going to be 12, 3 carbons, right? So 12 plus the last one is also 12. And then there are 2 oxygens, so that's 32. And then there are how many hydrogens? That's I think 6 hydrogens. So can anyone tell me what's this 50 plus 74? Is this 74? Can somebody do the math?
Yeah, it's 74.
Yes, sir, it is 74, yes.
Achha, so the next one, you might have an M plus 1 peak. Why? Because one of the carbons would be 13. And it could be any one of them. So there are 3 separate events. 32 is 2 oxygens, and so this would give you, I think that would give you 75. And then there would be an M plus 2 peak as well. Okay, 2 of the carbons could be 13. And you're going to get something at 76. And there would be an M plus 4 peak as well. एक और number से ज़्यादा हो जाएगा. Why? Because all 4 of them could be 30. All 3 of them could be 13, right?
Yes.
And this would be, I think, 78. तो खाली जो molecular ion है ना, उसकी इस molecular ion की, let's say it's an ion, there would be 4 different deflections because there are 4 different masses.
Sir, M plus 3 peak and 77.
Sorry, M plus 3. And this is 77. As anyways. Now, what's the probability of getting all of them as 12? That would be 98.9. Okay, that's going to be 98.9 into 100 over 4 times. So power 4 ho jayega. Can somebody do this? Is this coming out to be 90? It should be coming out to be, sorry, not 4, 3. Cube ho jayega na, it's 90. I mean, this has the probability of 98.9%. This also has a 98.9% chances. This other one is also 98.9%. So kitna banta hai? What's 98.9 divided by 100? Kya hai? Kisi ne kaha?
0.967.
Which is approximately, like if you multiply it by 100, so it's in percentage, that's approximately, if you round it up, it's approximately 97%, right? Is that clear? Or फिर इसका क्या chance है कि what if one of them is 13, right? So what if one of them is 13? That would be 1.1 divided by 100 into 98.9. And into 3, because there would be 3 separate events. Either the first one is 13, or the middle one is 13, or the last one is 13. So इसको अगर round off करो ना, that would come out to be approximately 3%. ठीक है? Or इनको, these would be hardly detectable with their relative. I mean, you can do the math, but these two would hardly be detectable. So you're not really interested in the M plus. I mean, you're only interested in the M plus 1 and M peak, because these are the ones that will be detected. इसकी percentage बहुत कम हो जाएगी. मतलब 1.1% into 1.1% करोगे, that would be a very low percentage. 1.1% cubed is going to be a very small value as well. So we're only interested in the M plus 1. So again, this kind of proves our point. Okay, what was our point? कि अगर 3 carbon atoms होंगे ना, तो what will happen? What will happen is कि your mass spectroscopy will have an M peak and will have an M plus 1 peak, and the relative abundance would be approximately 97%. And for this, it's going to be 3%. ठीक है?
Sir,
Yes.
98.9% is the probability of carbon-12, yeah?
Yes.
Okay.
ठीक है. तो लेकिन ये idea clear है? अच्छा, secondly,
Yes, sir.
you use this formula, which is because the probabilities are never actually going to be. I mean, if you're given just hold on one second. अच्छा, listen. इस फॉर्मूले पे आ जाते हैं कि what does this formula mean? ठीक है? And we'll just do questions now. ठीक है? We're done with mass spectroscopy. This fragmentation के ऊपर थोड़ी सी बात करनी है, but this is about it. Now remember this thing, 99:1. If they give you 99:1, that means one carbon atom. If they give you 98:2, that clearly indicates it's got two carbon atoms. And if the third one, if they give you 97:3, that clearly means it's three carbon atoms, right? But they're not going to give you this. I mean, they're not going to quote the ratio in the same way. For example, 1:2 can also be written as 30:60, right? So the point is that the numbers can be different. Is that idea clear? Okay. I mean, is this point clear that they won't tell you that it's 97:3? The ratio would be the same one, but they're not going to use the same numbers. Is that idea clear?
Yes.
Achha, so that would
So what would they use?
so that would kind of make things slightly confusing. So for example, if I just open the so remember that you're not going to see any questions in AS because this has just been added into AS. So I'm taking the A2 questions. It's been shifted from A2 to AS, this thing. And so I'll explain what they will use. For example, look at this question. Okay, remember this thing will come mostly in your organic questions. So they've given you the M+1 ratio. Now M+1 ratio is used to figure out the number of, it's used to figure out the number of carbon atoms, right? That's what we talked about. So it's used to figure out the number of carbon atoms, but the ratio that they gave you is 2.5:74. So what you're going to do is you're going to use that formula. There's a simple formula, and that is you can figure out the number of carbon atoms. The formula is 100 over 1.1 into the M+1 height divided by the M height, which in this case would be 100 into divided by 1.1 into M+1 is 2.5 divided by 74. So quick, jaldi se bataye ki kya aa raha hai? Mind, can you calculate this? Anyone, what do you get for this?
Um, 3.07.
Okay, so that's around 3 carbon atoms. So basically you're going to round this off that this has 3 carbon atoms. So this is the formula that's written. So I'm going to use 3:97 in the same formula. So it's number of carbon atoms. That would be 100 over 1.1. So if I've just used it over here. So I know that if the ratio had been given like this, it would have been very clear that it's got 3 carbon atoms. So even if you substitute this back into this, M+1 is 3. M is 97. If you do the multiplication, it's going to give you 3. But the confusing part is, so you'd have to use the formula in all cases. because the ratio would not be given as 99:1. It would be given in some other form. Is that clear?
Yes.
So just make sure you know this formula. So we'll just quickly do questions. So you figured out the number of carbon atoms in this question, right? And that's the number one thing about mass spectroscopy. You'll be asked to figure out the number of. Here's another one. And they're seeing that there is 0.9 mm+1 peaks. So what you're going to do is they'll just ask you to figure out the number of carbon atoms, and that would be 100 over 1.1 into 0.9 divided by 20.4. Is case mein, what do you get for this?
Four.
Because that would indicate it's 4 carbon atoms. So the NMR part is obviously still in A2, so you don't have to do that. I'll try and figure out the other questions as well that we talked about. Again, m+1, so you can figure out the number of carbon atoms. It's 100 over 1.1 into 0.15 divided by m+1 divided by m. क्या बन रहा है इसका?
3.
Okay, so that's 3. Anyway, so we'll be asked about this. Let's try and figure out questions related to chlorine and bromine. Hopefully there are some in this one. Let's talk about this one. Okay, he's saying that there is an m+2 peak and the ratio is, what is 14 ratio 43.0? I mean, what is this ratio? Again, it's, हमने क्या पढ़ा था? हमने पढ़ा था वो हमने summary का लिखी थी. Where did we study? The m+1 has to do with the ये जो box था. We told you, okay, if a molecule has 1 Br, there's going to be an m+2 peak, but the ratio is going to be 1:1. Which in this question is not really 1:1. This is not 1:1. ये ratio क्या बन रहा है? It's I think approximately
1 to 3 around.
so it's 3:1, right? So or m+2. So इसका मतलब है कि it must be, it's not bromine, it's actually 1 chlorine. Okay, there's going to be an m+2 peak and the ratio would be 3:1. अगर 2 chlorines होते ना तो फिर वो m+4 भी बनता. If you had 2 chlorines, अगर 2 chlorines होते ना तो एक और mass भी आ जाती उस particle की, ठीक है? It would have been a different mass as well. There would be a third different mass and the ratio would be 9:6:1. So this thing over here indicates that, it clearly indicates that the molecule has 1 chlorine, right? और m+1 का भी ratio दिया हुआ है. इससे आप क्या figure out करोगे? That would be, you'll be able to figure out the number of carbon atoms. ठीक है? We're not going to do any more math. लेकिन is the question clear? उससे कहा है what element is indicated. ठीक है? ये clear है ये part?
Yes.
let's see if
Yes, sir.
so let's see if I have, फिर हम fragmentation discuss करते हैं. वही m+1 का दिया हुआ है. ठीक है? अगर bromine का आ जाए, हाँ ये वाला कर लो. Okay, yes.
Which element was the m+2 peak in the previous question?
It was chlorine because 3:1, right?
Oh, okay.
मतलब वो था ना कि if a molecule has 1 Cl, then there's going to be an m+2 peak with the ratio 3:1. So that means it's 1 chlorine. If it has 2 chlorines, there's going to be m+2, m+4, 9:6:1. ठीक है?
Yes.
And for bromine, now this next question is about bromine. So if a molecule has 1 bromine, there's going to be an m+2 peak with similar heights, 1:1. ठीक है? But be careful about the ratio, because they're not going to give the ratio probably in the same way. 10 ka ratio is the same thing. It's 1:1. So this question is saying, okay, there's an organic compound N, it produced a mass spectrum. The m+1 is given, so that will give you the number of, you can do the math, number of carbon atoms, right? And it says which had an m+2 peak of similar height to the M peak. So that means the M and the M+2 peak had similar heights, 1:1. So that, what does that mean? It's got one bromine. Is that clear?
Yes,
Yes.
sir.
तो बाकी इसमें कोई ज्यादा साइंस नहीं है, बस वो कभी कभार ना what they'll do is they'll ask you about maybe they'll ask you to calculate the probability of the same thing mm+1. Okay, let me just he's saying if a given pesticide contains 2 chlorine, deduce the relative heights of the mm+2 and m+4. So this one has to do with math. They're actually looking for your working as well. Okay, so M आएगा जब दोनों chlorines कौन से होंगे, 35 and 35, right? Sorry, not 13. It's going to be 35 and 35, right? So कितना बनेगा? It's going to be 3/4 into, and it would be 9/16. Okay, we did the math on the board. Is that clear?
So we just say 9, 6, and 1.
In this one, I think you would have to do some math. You would have to show some math,
Like so, like
like the one that we did over here.
would you say out of 16, after 16? I mean, out of 16, 9 of them would give
Huh.
peaks at that.
So it's going to be 9:6:1. Deduce the relative heights. Okay,
Yeah,
both
so
of,
we just need to write 9, 6, 1, right? 9:6, not 6, 1.
yes.
Yeah.
फिर ये question भी वही है कि it's what's the mm+2 if the pesticide contained 1 chlorine rather than 1 bromine. The 1 chlorine के case में it's going to be 3:1. In the case of bromine, it's going to be 1:1. It would have equal probability, right? ठीक है, clear?
Yes.
So quickly, we'll also do the importance of fragments. Some importance of fragments. So why are fragments important? Just one second. You follow the class नहीं है अभी 5 मिनट के लिए. अच्छा, fragmentation. Fragmentation is the fragments give you some very important information. For example, I have a molecule and I'm getting different fragments. I got a fragment like this is what the peak looks like. I mean, this is the mass axis, mass to charge axis. I'm detecting something with a mass of 14. I am detecting something with a mass of 16. I am detecting something which has a mass of 28. I'm also detecting something which has a mass of 30. And I'm detecting something which has a mass of what is 14 plus 4, 28, 28 plus 16. That's what is 28 plus 16? It was 30, 44, I think. I say anyways. So I'm detecting all these random fragments. Which one is the molecular ion peak? इनमें से कौन सा particle is the molecular ion?
The 30 and 28.
नहीं, this is the heaviest one is the molecular ion.
Ah, okay.
मतलब वो हमने किया था ना कि जब आप mass spectroscopy करते हो तो you get the biggest ones, the heaviest one are your molecular ions, right? And then you get these tiny fragments. I mean, the bigger molecule breaks down into smaller, tiny pieces. Is that clear?
Yes.
अच्छा, तो अब ये है कि so the fragments are always the tiny ones, the lighter ones. So these are your fragments. ठीक है, so different particles getting detected at different masses. So these over here are your अब इसमें बताना है कि can you figure out 44 by just looking at the fragments? What do you think is this fragment, the tiniest one, the smallest one? What is 14? Which particle will have a mass of 14? मतलब किसकी atomic mass 14 होती है? Which atom has a mass of 14? That's nitrogen, right? Is that clear?
Yes.
Acha, which small tiny fragment will have a mass of 16? So that is going to be oxygen, right? Acha, so the bigger fragments are basically, मतलब इसको इस तरह imagine करो कि where's the fragmentation? Just a second. इसको इस तरह imagine करो, you've got this bigger molecule and you get bigger fragments, and those bigger fragments break down and they produce even tinier fragments. Those tinier fragments would break down and they would produce a carbon fragment, right? So by looking at the fragments, by looking at the detection, you can sort of build the molecule up, starting from the smallest ones. तो मुझे तो ये सबसे smallest हमने atoms fragments कर लिए. 28 would probably be a combination of these two, right? So how do you get 28? But the just smaller particles, and they would sort of combine to form this bigger particle, right?
Yes.
So when you get 28, 28 would either be two nitrogens, right? Joined together.
Yep.
Is that clear? How do you get 30? 30 would be 30 is going to be
Oxygen and nitrogen.
okay, so it's going to be a nitrogen and an oxygen bonded together. So what do you think this biggest molecular ion is? Okay, इसी को तोड़ के all the fragments were produced, right? So what is this bigger one? But it's obviously a combination of nitrogen and oxygen, right? So it's going to be N2. N2O plus 1, that gives you 44. This was your bigger molecule. It broke down, you got an NO fragment from it, you got an N2 fragment from it, it broke down into even smaller pieces. An O plus 1 fragment was produced, an N plus 1 fragment. So these tinier fragments were produced from these bigger molecules. Is this clear?
Yes.
ठीक है, मतलब मैं इसको वापस उसके साथ कर लेता हूँ, compare के. Remember the molecular ion किधर गया हमारा? So the idea is, remember the molecular ion is basically a combination of these tiny, the bigger molecular ion is a combination of these fragments. The CST plus 1 is a part of that. The Cl plus 1 is a part of that. So it's like a puzzle. Like if you see these smaller pieces and you can figure out the smaller pieces, so by doing some intelligent guesswork, you would be able to figure out the original piece as well. Like if I give you all these 4 pieces, and I told you that it came from a molecule, I didn't know what this molecule was. You could have made some intelligent guesswork, done some intelligent guesswork, and you could have managed to figure out this molecule. Is that clear? But it's not always going to work. It's just a lot of guesswork. You would have to make a lot of guesswork, and then you would be able to figure out. So I'll just do one question very carefully, one question very quickly. अच्छा, फिर molecule to molecular fragmentation pattern is also different. So for example, I just saw one molecule, the cyclic structure tha, just a second. There was this question. I think चला गया. ये वाला. Question ये कि what's the difference between the fragmentation pattern of these two molecules? I mean, this one over here, this one over here, and this one over here. Which fragment will be produced in this one and can never be produced in this one? Like the two separate mass spectroscopies that are being done. दोनों का formula एक ही है. Both of them are C3H6, right? And what we're going to do is we're going to use mass spectroscopy to figure out which one is which. तो मुझे बताओ कि over here I can get a CST fragment, right? I mean, the CST fragment can be detected. The CST fragment has a mass of what? 15, right? मुझे बताओ, can I get a fragment over here, a piece of this molecule that will have a mass of 15? Is that possible?
No.
क्योंकि
No.
या तो CH2 का fragment बन जाएगा, so CH2 is definitely not 15, it's 14. ठीक है. या फिर ज्यादा हो गया तो साथ वाले को भी बीच में इंक्लूड कर दो. So maybe this carbon can also combine with this, right? And this piece might break away and it would form a C2 H2 plus 1 fragment, but that would be much bigger than 15, right? It would be 12 plus 26, right? So masla, you're never going to get 15 in this one. 15 kabhi nahi aane wala. Is that clear?
Yeah.
So the fragmentation pattern, you can get some idea about the structure of the molecule. Okay. कि C3H6 है और आपने figure out करना है कि which one is it. So you can sort of look at the fragments. A 15 fragment will never be produced in this molecule and can never be produced. That's not possible in this one. ठीक है, clear है?
Yes.
तो बस ठीक है, बाकी फिर ना ये वरना तो टॉपिक खत्म हो गया. That's about it. ठीक है, just remember M plus 2 and M plus 4, number of chlorines, number of bromines, number of carbon atoms, and number of carbon atoms का formula वो याद रखना है. Fragmentation patterns and bits and pieces of information, you can extract them. ठीक है, some of them. So I'll leave you with one question, just one question, and that is a slightly difficult question, but that's about fragmentation. ठीक है, तो ये question try करना, इसकी snapshot भी ले लेना. There's a molecule which has silicon, chlorine, and oxygen, and they don't have any isotopes. Silicon is 28, chlorine is 35, ये ऊपर लिखना चाहिए था, oxygen is 16. ये उनकी masses है. When you did mass spectroscopy, you got different detections. You got a particle detected having a mass of 133. Then you got a particle having a mass of 147. Then you got a particle having a mass of 147 में एक सेकंड रुकना मुझे इसमें 147 है ये. ठीक है, एक सेकंड प्लस नहीं just a second. I have to make this question. It's actually a past paper question. Sorry, ये गलती थी. This is actually 149. So I got a particle having a mass of 149. Then I got a particle having a mass of 247. Then I got a particle having a mass of 263. ये सारे fragments हैं, ठीक है. And then I got a particle, इसमें अगर मैं 263 पे आ गए, 263 प्लस अच्छा O को हटा, हाँ Cl35 है, 130. And then I finally got a particle with having a mass of 396. This is my molecular ion. You figure out karo, what is this? And these are all your tiny fragments. Okay, that's all your tiny fragments. This question aaya hua hai, hai? And they've told you that the molecule contains silicon, chlorine, and oxygen. These are the fragments. Try and figure out the exact structure, not just the formula, but the exact structural formula and the arrangement of the atoms in 396 based on by looking at the fragments. Is that clear? You guess karna iska, theek hai? And I'm sending this in the group as well. Make sure you post your answers. Try and post your answers there. Pesha galat ho. चले कल फिर डिस्कस करते हैं इसको. ये तो खत्म हो गया, ठीक है. That's about it.
Okay, sir. Allah Hafiz.
Okay, take care. Hafiz.